Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on error management in Plsql, and the focus of this lesson is on best practices for error management, and it's the first of two on this topic. Some quick reminders. You can download all the supporting code that I execute and refer to in my presentations and all the PowerPoint documents from Plsql Obsession, otherwise known as toadworld.com/sf, which you can see right here. Lots of different resources for Plsql developers. Click here to download my demo zip with all the files that I use and reference in my trainings. Click here to drill down into the listings of PowerPoints for my various presentations. Make sure you're comfortable with the material covered in the previous lessons in this series. So what I've done in the other series, the other lessons, is cover basic concepts, defining, raising, and handling exceptions, how to continue past exceptions. So I've talked about the functionality within the Plsql language for dealing with errors and exceptions when stuff goes wrong. Now I want to talk about the best way to write code in your application for maximum readability and maximum maintainability of your code. So best practices for error management. In this lesson, we're going to talk about how you should avoid putting application code in the exception section. Then we'll talk about avoiding the suppression of exceptions, especially something as dangerous as when others, then null. I'll talk about the dangers of hard coding, error numbers, error messages, error logging mechanics. And after that, the next lesson will really finish up by talking about the importance of setting standards as you write your code for error management, and also building and using a shared error management utility so that everybody does their error management logic in the same way. So first of all, no application code in the exception section. Well, as you know, Plsql is a block-structured language with three sections: declaration, execution, and exception. And each section should be used as intended. And if you do anything else, it's hard to deal with the errors, it's hard to understand the code, and therefore hard to maintain it. Now, in general, there's not a lot of ambiguity about what you do in the different sections. In the declaration section, you declare your variables and local structures. In your execution section, you provide one or more executable statements. But the exception section can give you some ambiguity because you can execute code in the exception sections. And there are some scenarios that lead to the putting of application logic, not error management logic, but actually application logic, right in your exception section. Two common scenarios: deliberately raised exceptions and what would be called unfortunate exceptions, which I'll explain as we go through the examples. And the basic rule is that you want to avoid putting any of your application logic in the exception section and only put error management code in that section. So let's start off by looking at exec DDL from file bad news. So I'm going to go to my demo directory, and this is all the same code that you have access to when you download the demo zip. And what I've done is write a utility called exec DDL from file. And what you do is pass in the directory the name of the file. It uses utilefile, the file.io package in Plsql, to read the contents of the file and then execute the contents of that file as a DDL statement. So for example, if you took advantage of my parse package at parse.pkg, this is a set of DDL statements that create the parse package that allow you to parse delimited strings. So you could pass in the information for this file, it would load up all this code as a big string, and then would execute the DDL statement. So let's take a look at the structure of this program. So there's the declaration section, the execution section, and the exception section. And I declare my file handle. I declare the array that will retrieve the lines of the file. I open my file, and then I've got a loop. And the loop says, well, get the next line from the file and put it in to that next element in the collection. And that's it. That's the entire executable section. Now, that looks strange for a number of reasons. Number one, it looks like an infinite loop. There's no exit statement, which is kind of scary all by itself. And second, there's no logic in the executable section to actually execute the DDL statement. So what the heck is going on here? Well, what's going on is that as you learn about utilfile, which you can do in some other lessons that I'll record, you learn that utilfile getLine raises an exception, in fact raises no data found when it reads past the end of a file. That was a bad decision on Oracle's part, but that's the way it works. In other words, utilfile getLine deliberately raises an error to indicate that you've read past the end of a file. So when you're working with utilfile getLine, what you need to do is include an exception handler for no data found. And what I've done in this program is then close my file and then put in the code here to actually execute the DDL statement. And I can do that by using dbms SQL parse to actually pass in an array of lines. And Oracle will put it all together into a big string and then execute it as a DDL statement, which I then do right here. And finally close the cursor. So here's the problem. Here's a classic scenario of a deliberately raised exception, utilfile getLine raising no data found, forcing me into the exception section of my block, and then I have to finish up my application code down here. And that makes that what I end up with is a piece of code that's really hard to understand, hard to maintain. Because what we tend to do is look in the executable section for our executable code. We don't see it there. We may not even look in the exception section, and if we do, it's a rather strange place to put all that logic. So there's an example of a deliberately raised exception forcing me to go into the exception section and seemingly forcing me to put my application logic down there. Now I'm going to talk about how to get around it in just a moment. But first, let's go on to the raise if NDF SQL script and take a look at an unfortunate exception and what that means. Here's a function called ID for name. And what I do is look up the department ID for the department name. Very simple. I do a select statement, pass the department ID I find into a local variable for that name, and then I return it. Very simple function. Now notice I have no exception section. Classic errors that are raised by select into are no data found and too many rows. Now in a situation like this, too many rows is probably a big problem in my application because I'll have multiple departments with the same name. It's likely a data integrity issue. So that's a real hard error, an unexpected error. But no data found is not an unexpected error. It's unfortunate. In other words, yeah, maybe the row doesn't exist, but that doesn't mean there's anything wrong. In fact, I might deliberately want to use ID for name to find out if a row exists or not. For example, here's my application code. I've got a department staging table that's got lots of data in it. I go through each row in that table, and I ask, if a row already exists for that department name, then update the department with the new information. Otherwise, add the department. Now I want to take advantage of my existing reusable code, like ID for name. I can quickly call that function, get the ID, and assuming I've got an ID and no exception was raised, I can then do the update. If my function raises no data found, I say to myself, hey, that's not a big deal. It's not even really an exception at all. It's not an error from my perspective. It's just an unfortunate scenario. I trap it, and I do my add. And once again, we end up with a situation where I've got my application logic sitting in my exception section, making it hard to maintain and read this code. So no data found, I think, is a really classic common example of an unfortunate exception. Yes, your code or Oracle's code raises the exception, but in some circumstances, in fact, maybe in most circumstances, it's not even an actual error in the context of the application. But again, I'm forced into the exception section and then putting my application code there. So what should I do about it? How do I avoid application code in the exception section? Well, one thing you can do, and this is for deliberately raised exceptions primarily, is encapsulate the code that raises an exception. You can put a block of code begin end around the code that might raise an exception. You can trap that exception, and then you can turn it into something else, a status code, a Boolean flag, something that indicates this different scenario occurred, but it's not an error, and you don't want to treat it as an error in your code. Another thing you can do, and this is more relevant in the case of the no data found exception, is give the caller of your program the option to decide if the scenario that occurs is an exception or simply a different data condition. Let's take a look at the two scenarios, these two approaches. Let's take a look at a rewrite of exec.ddl from file. So in my previous example, in the main body of my code, the execution section, I simply read all the rows from the file. Then I'm forced into my exception section, and then I execute my DBMS SQL call. Now what I want to do is come up with a easier to understand and maintain piece of code. Let's take a look at my new execution section. I open my file. I have a loop. I get the next line from the file. Notice I'm not calling util getLine directly. I get the next line, and oh, I've got a Boolean flag. Am I at the end of file? And if it returns false, then I just keep going. If it returns true, yes, Stephen, you reached the end of your file, then I stop, I close out my file, and then I execute my DDL statement. So I've created a small subprogram that simply does all my DBMS SQL work. But notice, it's in the executable section now, all of it. And I can read it, and it makes sense, and it's not scary because there's not an infinite loop or what looks like an infinite loop. It makes sense. And then, in my exception section, all I do is trap errors that might have occurred. For example, I might get a lot of different errors in util file doesn't exist, invalid directory. I might have DBMS SQL errors. I trap the errors, I log them, display them, re-raise, whatever I'm going to do. But notice that the exception section only has exception handling code in it. Now the way I was able to do this is I didn't call util getLine directly. Instead I created my own little encapsulation of it. So I created a procedure to wrap around Oracle's procedure. So it calls getLine, it grabs the line back, and it traps the no data found exception. Now, if the no data found exception is not raised, then end of file is false. If no data found is raised, then end of file is true. I'll pass back a null line. But notice now that the actual call to that program no longer forces me into the exception section because I've narrowed the propagation of the exception here. And then in the outer block, there's no knowledge or awareness that that particular error occurred. If some other error occurred or exception was raised, like invalid path, something like that, this program would not trap it. And it would come out unhandled and stop the program. That's appropriate. That would be an unexpected error. But in this case, I do expect it. It's deliberately raised. I'm going to say that's not an error as far as I'm concerned. That's no exception in my code. And that's how I do it. So I end up with a block of code that's much easier to understand and maintain and concentrates all of my exception handling logic and only my exception handling logic inside that exception section. And now let's take a look at raise of no data found. So I've talked about this first approach of encapsulating the code that raises the exception, passing back something else. And the second is give your caller of the code an option to decide if it's really an error in their situation or simply a different data condition. So raise if no data found. In my first instance, I had this function that didn't trap for exceptions. It simply raised or passed out no data found and too many rows. And then I trapped the exception and was forced into the exception section. So what I'm going to do now is make my function a lot fancier. I'm going to say look up the name for this, look up the ID for this department, but also let me know, do you want to treat no data found as an exception, true or false? And the default is false. And what is my no data found value? In other words, if you don't want me to raise no data found as an exception, you're going to pass back a value. And the default might be null, and that's usually a good indicator of nothing found. But in some cases, null might be an acceptable value, so you might need to pass in something else. And you have all of that flexibility. So now in my local program, I get the ID for that name and return it. If something went wrong, I check for no data found. And if the user, the caller of the program, wants me to raise the exception, then I raise it. Otherwise, I return the no data found value, indicating that no data was found, but I didn't pass an exception out. But for my other exceptions, like too many rows and anything else, that's an unanticipated error. And in this case, I'm demonstrating the use of the Quest Error Manager, a shared or reusable utility that I'll be talking about in the next lesson, the final lesson on best practices. And so we'll come back to that. But the idea is that I'm treating these two different exceptions very differently. Unexpected error, I want to log the fact that it occurred and raise it back out. No data found, I'm going to give the user of my program a choice. Do you want to raise it or not? And once I've done that, I can go back to my original application. And now I call my ID for name function, get me the ID for this name. I do not want to raise no data found. And I'm going to use the no such department, which happens to be -1 because departments can never be negative, department IDs. So that would be my no data found value indicator. And then after I call my function, I can say if the ID returned is equal to no such department, nothing was found, so I will add the department. Otherwise, I'll update the department. Now this code is much easier to read. There's no exception section. Of course, there could be. I probably should trap the exception in a production piece of code. But in that exception section, we will only have the exception handling logic. So that's the recommendation around how to avoid application code in the exception section. Let's move on. Avoid suppression of exceptions. Now I need to be clear here. In the previous 3 sessions of this lesson, I talked about how to continue past exceptions. So an error occurs, but I want to keep going. So that's a form of suppression of exceptions, and that's a perfectly legitimate thing to want to do. But, and I talked about techniques for doing it, but the main thing is you might want to suppress the exception. You might want to continue going on, but you don't want to lose the error information. And what you really want to watch out for is the I don't care exception section, in which you say, when others, if anything goes wrong, then null, just ignore it, just keep on going. There might actually be a reason to do that. It's very rare. There might be. But certainly just doing that by itself and not explaining what you're doing is very, very dangerous. So there are some scenarios, usually when you're running some scripts, some blocks of code that you want to run each weekend to say, refresh your test environment, drop all your tables, whatever, in which you're just doing some stuff to a test schema. It really doesn't matter if you get an error, just keep on going, just get as much done as you can. But that's a fairly unlikely scenario, and in general, even if you don't really care about the error, you should at least consider logging the error for later analysis, or include a comment that says, hey, I know this is probably not the best thing to do, but I did it anyway, and I realized what I was doing. So here's an example of dropping a table, and you know what? If I couldn't drop the table, that's okay, just keep on going. When others, then null. It still doesn't make a lot of sense. You'd probably want to put in a specific exception like when, table not found, and so on and so forth. But at least I've got a message here saying, I thought about this, I did this on purpose, be aware. In general, though, avoid the suppression of errors, and instead log errors, re-raise them, call dbms output.putLine to display them. Do something, but don't ignore them. Next, and very, very important, do not hard code error codes, messages, and error logging mechanics. This is probably the most important rule for writing high-quality code in general. Never repeat anything. If you can follow this rule in all of its ramifications, you will end up with some really excellent code. And certainly, there are a lot of opportunities for doing this with error management. And if you're not very careful, it's easy to hard code error codes, like Oracle error codes, -24381, -1855, etc. in your applications. You'll expose the way that you log errors, for example, doing an insert into a table. And of course, you often hard code error messages, all points of brittleness in your application that make it easy for the application to break over time and make it hard to upgrade the application for new features in Oracle. Let's take a look at an example. Here is a very messy exception section. In fact, let's take a look at the code itself in Toad with some color coding just to be able to see it more clearly. So I've got some application that does some stuff with companies. And the documentation, that the requirement said, look, if you don't find a company for that ID, it's not that big a deal. You need to record the error, but then you can allow the enclosing block to continue. In other words, don't raise the exception back out. It's just something that needs to be noted that it occurred. If you get a match on the same company, you get a dupe val index, then you need to let the user know that the company name already exists. And if anything else goes wrong, you need to record the fact that the error occurred and then re-raise it back out because you don't know what it is, it's unexpected. You got to stop the calling block from continuing. So those are my exception handling requirements, and I've implemented them exactly as requested. I do an insert into my log table for no data found, recording the fact that I couldn't find a company. I've got the program name, a column in my error log table for program name, when it occurred, who is running this code, and I put that in my table. Dupe val index, well, I need to communicate an application-specific error back to the calling program back to the host environment. So I just pick one of those numbers from minus 20,000 to minus 20,999 for raised application error. And I pass back a message as well. Finally, if anything else goes wrong, I insert it into my log table, and then I re-raise the exception. So the nice thing about this code is that it's self-documenting. You can read it, it makes sense, you understand exactly what the person is doing here. The bad side of this piece of code, exactly the same thing. Everything's exposed. You can understand every single step of the way of what they're doing and how they're getting it done. In this case, that's a really bad idea. I'm exposing the mechanics of my error logging. I've got hard codings for message text, for error numbers, for other messages, for the names of the programs. So lots of hard coding and lots of exposure of the mechanics of how you get things done. What's the wrong with that? Well, let's step through these one at a time. So one recommendation is that you should never hard code an Oracle error code. There's not an example in the piece of code I just showed you, but we'll look at an example. Oracle does not provide a name for all their error codes, but you can do it yourself, and we've covered this feature in an earlier part of the lessons on pragma exception init defining exceptions. So here's a piece of code that has two references to Oracle error codes. So in the exception section, I ask if the SQL code equals minus 24,381, if the SQL code equals negative 1855. So there are two specific errors that I need to trap and write some special code for. And I did it. What's wrong with this? Well, somebody coming along to this code later will likely not know what these error codes mean, which means that they're intimidated by the code. They think to themselves, wow, Stephen really knows Plsql well. He knows what those error codes are. I guess I should know too, but I don't know. And that makes me feel kind of dumb. You don't want to do that to people who are maintaining your code. You want them to make them feel really welcome in your application code, comfortable, able to maintain it and make changes without having a nervous breakdown. So what you should do instead is give names to all the Oracle error codes, or any kind of error code. Give it a name with the exception declaration. Use pragma exception init to associate it with the error number, and then you can, in your exception section, specify when a certain named exception is true, when the for all failed. Now it's much more understandable. No more hard-coded values. So avoid any hard codings of Oracle error codes. Now let's talk about raised application error. This was discussed in the raising exceptions section or lesson of the series. And raised application error is a program that allows you to communicate back to your users an application-specific message. And almost always when working with raised application error, you end up with hard-coded error numbers and error messages. And you basically, most organizations let developers choose whatever numbers they want. Oh, sure, choose minus 20,700, 600, 500, minus 20,764. Nobody else is going to pick that number. But of course, somebody could. So in general, you don't want to write code that looks like this, and you don't want to leave it up to the individual developers to decide what numbers to use and what messages to use, because you end up with chaotic code, conflicting messages, lots of hard coding. What should you do instead? Build a repository of errors, and so all the application-specific errors are stored, for example, in a table. And then you can actually, if you want to get fancy or use some of my code that I'm about to show you, you can generate a package that provides names for every one of those errors, and the developers can then use those error codes, those error names, and error messages by name. Now, my real recommendation for raised application error is don't use it at all. I'll come back and talk about this in the last lesson, which is on how to use a shared reusable error management utility. But for now, let's take a look at the message info script. So what I'm going to do is create a table called message info, and it stores very generic message information. The message code, the message type, I can store warnings, information, errors, the text, the name, basically the identifier in Plsql, and descriptive information. Then I'm going to create a message info package that allows me to return the name for a given error code. Returns the error message. Gets the name for an error based on its code and type, but most importantly, generates a package. Now, I'm not going to go through all the details of this package itself. You can take a look at it when you've got some time. But here's what I mainly want to show to you. I can insert my error information into the table, so I'm going to define the balance too low exception as minus 20,100. And there's the identifier that I'll use in my Plsql code. Minus 20,200 is employee is too young. Minus 20,984, the example I just showed you, duplicate company. So I define these inside my table. And then what I can do is call the gen package program to generate an error numbers package. So let's try it. Let's see, did that work? Nope. Let's run the whole thing from top to bottom. And here's what I see. Here's my error numbers package. And it declares an exception. And then it declares an error number to go with that exception using the number that was inside the table. Let's show that again up here. Whoops. Bring that back. So I define the exception here. There's the error number. So I get an exception, the error number, and I associate the two together. And I do that for each one of the error codes in my table. Here's the exception duplicate company. So now I've got names for the underlying error codes. And then I can go back to my original information, my original bad exception section, and I can turn it into something that looks like this. Here we go. Now I haven't talked about this generic error package. I'll talk about that on the next slide. So don't worry about all these details, but notice when I reference my duplicate company, I no longer have negative 2984. Instead, I reference it by name. So anybody looking at this code says, oh yeah, that's the duplicate company error. And if it ever needs to change, like not minus 20,984, minus 20,706, you don't have to change your application code. So there's an example of defining your errors inside a repository, generating the code to support it, and then you can reference that package and the elements by name. So that's by far the best way to work with raised application error. And of course, you can build an application, a front-end application around the message info table so everybody can look at what errors are defined, they can add new ones, they can change existing information, and regenerate the package. Now let's talk about hiding error logging mechanics, probably most important of all. So, in that original messy piece of exception handling code, notice I had my insert statements directly in the error log table. Why not? That's the error log table. These are the different columns. Why not just insert directly into it? Well, that would be perfectly fine as long as there's never any reason to change the structure of the table and what we insert into the row. Now, if you ever hear anybody say, oh, I never need to worry about that, or that's never going to change, you should be very wary. Don't believe them because everything changes in our environment. And certainly there's every reason to think that over time you might want to add more information to the error log table. So this is a very dangerous and faulty assumption. For example, when you upgrade to 10.2, or when you learn about this fantastic new feature called DBMS utility format error backtrace, that function can be called inside your exception handler, and it returns the line number or the stack back to the line number on which the error was raised. Very important information. I talk about it in the handling exceptions lesson. And I would really want to go back to every single one of my insert statements for my log table, and first of all, add a new column to the log table for the backtrace, and then call the backtrace utility right here. So I really should go back to every single exception handler and change the insert statement to add the format error backtrace. Wow, that could be a lot of work. That could be a big headache. How do I even find all the exceptions where I'm doing the inserts? Well, I could do that, but still. The problem of exposing the mechanics, of showing everybody how I'm doing the logging, is that if there's ever any change, I don't want to log to a table anymore. I want to log to a file. I want to add more information into my logging mechanism. Then it's virtually impossible to do it. And what you really want to do is hide everything. Hide your error logging mechanics. Never show how it's being done. For one thing, you want to be able to spend the minimum amount of time possible inside the exception section. Just write a little bit of code and get back to work. And instead, you just call a procedure to do all the logging work for you. So you're much more productive and you improve maintainability of your code. So what I'm going to do is show you right now a very simple error logging package. And in the final lesson, I'll show you a much more expansive and complete generic reusable utility. So the error package. This is really more of a prototype, proof of concept, than something you'd want to use in a production application. In my error package, I've got an example of defining a name for an Oracle exception, the -24381. I have two programs to raise errors. One takes a SQL code, and one takes an error by string, by name, if I wanted to use that approach instead. Record and stop means basically record the fact that the error occurred and re-raise the exception, stop the outer block. Record and continue means record the error, but keep on going. And error text looks up the error message info for my error number. Now, I'm not going to go through all these details of this utility. You can certainly check it out on your own time, but let's take a look at some of the highlights. First of all, record and continue simply logs the information into my log package, log table, and I actually use another package, my log package, to do that, also a part of DemoZip. Raise error does two things. Record and stop. Record and stop does two things. Record and stop says record and continue. In other words, record the fact that the error occurred, but don't re-raise an exception, and then raise the error. So record and continue, we just covered. Raise error passes in the error, passes in the message, and in fact, let's take this out. That's a bug. I'm recording when I shouldn't. This program just raises. So basically what I do is then say, well, look, if the errors between the Oracle error range, -20,000 and -20,999, for a user-defined error, then use raise application error to raise it. If the error number is positive, and it's not 1 or 100, then I'm assuming that the user has decided to use positive numbers for their own errors. That's okay. And I'll simply pass the message information back using raise application error. And notice my message contains the message that's passed in, plus optionally the error stack, error backtrace, and call stack. So notice, you don't have to call these utilities directly. It's done for you simply by relying on the utility. And then I've got some other special logic, including re-raising the exception, any Oracle error, by declaring and executing an anonymous block using dynamic Plsql. Again, we don't need to go into all the details now, simply to point out that the raise error program isolates and allows you to re-raise any kind of error that was raised in the back-end code, and all you have to do is say, well, record and stop. But you as the application developer don't have to know how you're recording. You don't have to know that you're writing it into a log table or a log file. It doesn't matter to you. You don't have to know how the error is being raised. You just know that this is the approach to take, and you follow it. And then you're much more productive, and the quality of your error management goes way up. So hopefully this gives you a little bit of a sense of the power of this kind of reusable utility. Again, in the next lesson, I'm going to go into much more detail of why you'd want to build something like this, the best way to do it, and I'll offer you an example that you can put into use in your application called the Quest Error Manager. And before we get to the conclusions, just to touch back into that good exception section, let's just do a quick comparison of the volume of code and the complexity of code. Notice this is very short, it's very easy to read, easy to manage. This code is a monstrosity that when you think about how it would scale across your entire application with hundreds of lines of extra code that you'd have to go back and manage, this is something you really want to avoid doing. So never insert directly into those tables. Okay, so conclusions. Make sure that exception handling sections only contain error handling logic. There should be no application code in the exception section. Log errors, even if you want to continue processing, don't just ignore or suppress your errors and say, who cares? Somebody's going to care at some time. If you're going to use raise application error, and again, I recommend that you don't, but if you are going to use it in your application, avoid all the hard coding that usually comes with it. Create a repository to store your errors and your messages, and then reference them by name. And the message info utility gives you a model for doing that and generating the code that you can use to reference those named elements. And finally, hide all the details of error logging mechanics. Do not expose the way you're getting that done. And I showed you a simple prototype for a shared utility. We'll look at a much more interesting and complete one in the next lesson. Next steps. Download the demo zip if you have not already from Plsql Obsession. Run the sample code that I ran in this lesson. Make sure you understand how it works, what the issues are, and how you can go about fixing them. There are a number of examples of before and after in this lesson, and that it's really important to look at the before and say, I see the problems with that, and look at the after and say, yes, I can see why this is better. And then proceed to the next and also last lesson in my error management series, standardize error management with a shared utility. Thanks for joining me. I hope you enjoyed this lesson, and I hope you enjoy your PL/SQL coding. Take care.